Welcome, Hornets. In this lesson, we're going to be taking a look at how do we use our calculators to find the equation of a tangent line. So we want the calculator to do the work for us, and we need to look at it carefully to be able to do it. So first thing we got to do is make sure we can put into our equation under y1, 3 natural log absolute value cosine 2x. Please be aware the absolute value is under math. Move the right arrow over 1 to number and and you'll see it as ABS. Okay, so let's go ahead and take a look. I'm going to zoom into my calculator first. Remember, we're looking at 3 natural log cosine 2x. If you haven't written that down, you might want to do that. 3 natural log absolute value cosine 2x. Here we go. Now, this isn't a difficult process. We just have to make sure we do it right. 3 natural log math number absolute value. Put in your cosine of 2x, close, and then close outside. Now, be aware, when I think of the 3 natural log cosine 2x and they wanted it pi over 6, I'm looking at, I'm saying, well, pi over 6 is between 0 and pi over 2. Now, when we do this graph, we're going to find that there is an asymptote. So just be aware. We're going to do our windows. We're going from 0. I'm going to do pi over 2, pi divided by 2. And for my y min, I want to go negative 10. And for my y min, y max, let's do a 2. Now there's the asymptote that I was mentioning a moment ago. Pi over 6 is to the left of that asymptote. So I'm going to just not worry about this. If you wish, you can always change your interval from 0 to pi over 4. That's where the asymptote is located at, but we don't care. So what we're going to do is we're now going to take a look, and we're going to program. Okay, program is right below stat. It's right above cosine, and we have to hit the second button to get there. So we're going to do second program. Okay, did you see that? Second program. What this does is it takes us to a very special field called draw. Now we want to draw the tangent line, and that's 5. The tangent line is 5. So we're going to hit 5. And they wanted it at pi over 6. So before we do anything else, we're going to do pi, that's second caret, divided by 6. Now when you hit enter, the calculator is going to do all of the work for you. It is going to find the equation of the tangent line, and you're all set to go. Now, if you would rather do some more work, there are other options. Please be aware, in order to get this, you have to go to second program and hit clear draw. It'll draw it again. Now, what we need to do is we need to find the equation of the tangent line, which would tell me that if I work with second trace, dy dx is the slope of the tangent line. So I'm going to do dy dx is 6, and I'm looking at pi. Oops, let's try that again. That's pi divided by 6. Now you'll notice, now it's going to give me the slope, the x, and the y. And I can write my equation as point slope form. Now, the other way, second program 5 at pi divided by 6 gives you slope-intercept form. So you have to decide what you want. Do you want slope-intercept form that's written right down here? Or would you rather work with point slope form, which requires you to work with your dy dx? Alrighty. So let's take a look at another example. Okay, be aware, this is my answer right there. Negative 10.392x plus 3.362. Going to y equals. Let's now zoom back out and see the second problem that we have here. Given the function y equals 6e to the 3x, the quantity minus 2, find the equation of the tangent line at x equals negative 1/2. So once again, go to your graph, go to y equals, and put in the equation. This is 6e to the power of 3x minus 2. Let me zoom in. Here we go. 6e is second divided by, to the power of is the caret. We have 3x. Move the arrow to the right and hit minus 2. Now we're going to go ahead. Once again, we want to look at where we're at, negative 1/2. So if I'm looking for the value at negative 1/2, then I want to think about, well, what's a reasonable domain? I don't want something so huge that I can't use it. So I'm going to go, oh, how about negative 1 to 0? Negative 1/2 is on that interval. So Windows, negative 1 to 0. Zoom fit. Might give us a large graph and we may have to adjust it. Let's go ahead and see what it looks like. Zoom fit. Now if it's too large, we'll just zoom in again. But this looks perfect. All right, so let's now take a look. We've got our graph. If we want point slope form, that's having the y2, the y1, and the dy dx, we hit second trace. Remember, trace is right there. It says calculate. We're calculating our dy dx right there, and it's happening at negative 1/2. So negative 0.5, you can write the fraction however you want. But notice it gives you the value. Y is negative 0.5. The slope of the tangent line is 4.016, and the y value is negative 0.661. So let's see what's going to happen if we do the program, the second program for the tangent line. Once again, that second program, right above the cosine or below the stat. You're going to hit 5, the tangent line, and then negative 0.5 or negative 1/2. Hit enter. Notice this now gives you the slope and the y-intercept. It's not telling you the y value itself. You'd have to calculate that and work backward. So be aware, depending upon what you want, look carefully and you'll be okay. Let's take in one more example, and then we're going to end this video. My hope is that you've seen a sufficient amount that you will be happy about it and feel content. So here we are. Our next example says, given the function y equals the sine of 3x squared minus 1, find the equation of the tangent line at both pi over 3 and 5 pi over 12. Notice 5 pi over 12 is just prior to pi over 2. So we're going to go 0 to pi over 2. We're going to graph this thing, and we're going to look for our two tangent lines. So here we go. Go to your y equals. You're going to put in sine 3x squared minus 1. Sine 3x squared, close parenthesis, minus 1. Let me zoom in on this so you can see what I've got. Once again, sine 3x squared minus 1. Go to Windows. You're looking at 0 to pi over 2. Hit zoom fit to get the best graph possible, knowing full well if it's too large, we'll just have to rewrite it. Alrighty, here we go. Now, decide how you want to write the tangent line. Do you want the tangent line to be written in point slope form? If the answer is yes, hit second trace 6. Now do pi over 3. pi divided by 3, hit enter. You have your slope, dy dx. You have your x value, 1.0747, and you have your y value, negative 1.148. Put it into point slope form. If, however, you would rather have slope-intercept, go to second program. Hit 5 and now put in pi divided by 3. Hit enter. You'll see the same slope, negative 6.214. Okay, but now we have our y value isn't shown. We see our x, we see our slope-intercept. All right, let's go ahead and go back. We're going to go back and clear this. Hit second program, followed by enter, clear draw. Gives you the graph again. We're going to do 5 pi divided by 12. Second trace gives us point slope form. When we use 6, we use 5 pi. Whoa, let's try that again. Pi divided by 12. We hit enter. Slope x, y. Or we do second program, 5, and then we put 5 pi divided by 12. Hit enter. Notice we now have the graph 3.260 minus 6.177. All right, Hornets, this is how we do it. I recommend you get some graphs and you practice doing this so that you're able to do it when the time comes. Thank you very much. Be well, be safe, and please take care. Thank you.